Have you ever wondered why, during a total solar eclipse, day turns into night and stars become visible in the middle of the day? It's a phenomenon that has fascinated mankind for centuries, sparking awe, fear, and intrigue in equal measure. Throughout history, people have looked up at the sky, their eyes wide with wonder, as the sun, our constant daytime companion, is swallowed by the moon. Cultures across the world have spun tales around this celestial event. In ancient China, it was believed a dragon was swallowing the sun, while the Vikings envisioned wolves chasing and catching the sun. The Native American Pomo tribe, on the other hand, saw it as the sun taking a reprieve to cleanse itself by plunging into the waters below. But beyond the myths and superstitions lies the fascinating science of solar eclipses. Simply put, a solar eclipse occurs when the moon, on its journey around the Earth, comes between the sun and the Earth. The moon, for a brief period, casts a shadow on our planet, giving us the spectacle that is a solar eclipse. However, it's not as simple as it sounds. The sun is about 400 times larger than the moon, yet it's also about 400 times farther from Earth. This cosmic coincidence means that both celestial bodies appear roughly the same size in our sky, allowing the moon to perfectly eclipse the sun at certain times. But even this doesn't happen every month. The moon's orbit around the Earth is tilted by about 5 degrees to the Earth's orbit around the sun. And it's only when these orbits intersect and the moon is in its new moon phase that the alignment for a total solar eclipse is just right. A solar eclipse is more than a spectacle. It's a cosmic dance that showcases the precision of our universe. But what really happens during a solar eclipse? To understand that, we need to journey into the cosmos. Imagine you are floating in space, watching the Earth, moon, and sun in their cosmic dance. As we know, the Earth orbits the sun, and the moon orbits the Earth. The Earth takes about 365 days to complete one lap around the sun, while the moon zips around the Earth in just 27 days, roughly. Now, these orbits are not perfect circles, but ellipses, slightly stretched out circles, if you will. And here's where the dance gets interesting. Every now and then, the Earth, moon, and sun align in a straight line. When the moon is between the Earth and the sun, it casts a shadow on our planet. This shadowy performance is what we call a solar eclipse. But not all shadows are created equal. The moon's shadow has two parts, the umbra and the penumbra. The umbra is the darker, central part of the shadow, where the sun is completely blocked out. If you're standing in the path of the umbra, you'll witness a total solar eclipse. The penumbra, on the other hand, is a lighter outer part of the shadow where only a portion of the sun is obscured. If you find yourself in the penumbra's path, you'll see a partial solar eclipse. And then there's the rare hybrid eclipse, which is a mix of total and annular eclipses. This happens when the moon is just at the right or wrong distance from the Earth, so it appears to be the same size as the sun, but doesn't completely cover it. So the type of solar eclipse you see depends on where you are in relation to these shadow zones. And there you have it, the Earth, moon, and sun in a celestial ballet, choreographed by gravity and illuminated by the fiery glow of our star. So that's the cosmic ballet that results in a solar eclipse. But what's the experience like on Earth? Back on Earth, as the moon begins to cover the sun, a strange phenomenon occurs. Imagine standing under the open sky, observing as the light around you subtly changes. It's not like the soft transition from day to night we're familiar with. No, it's different, eerie even. The world seems to be bathed in an ethereal twilight, a surreal blend of day and night, as if time itself is holding its breath. The temperature, too, begins to drop noticeably. You might even find yourself reaching for a sweater, a stark reminder of our sun's influence on Earth's climate. This drop in temperature can be quite drastic, especially if you're in an arid environment. As the moon continues to slide over the sun, we are treated to a celestial spectacle known as Baily's Beads. Named after British astronomer Francis Baily, this phenomenon is caused by the rugged lunar landscape. The sun's light peeks through the lunar valleys, creating a string of bright spots that look like a necklace of glowing beads around the moon's silhouette. And then, just before the moon completely obscures the sun, we witness the breathtaking diamond ring effect. It's a fleeting moment when only one Baily's bead remains, appearing like a dazzling diamond on a ring of light. This is the last hurrah before the onset of totality. But here's a question that might have crossed your mind. If a new moon occurs every month, why don't we see a solar eclipse each time? The answer lies in the moon's orbit. It's inclined at about 5 degrees to Earth's orbit around the sun, which means the moon, Earth, and sun don't always align perfectly to create an eclipse. A total solar eclipse truly is one of nature's most awe-inspiring spectacles. But how can we safely observe it? Staring directly at the sun can cause serious eye damage. But don't worry, there are safe ways to observe a solar eclipse. Now, you might be thinking, I'll just grab a pair of sunglasses and I'll be good to go, right? Well, not quite. Sunglasses, smoked glass, or any other improvised methods are not safe for viewing the sun. The sun's rays are so powerful that these methods cannot adequately protect your eyes from harmful solar radiation. So, what's the solution? Proper solar filters or indirect viewing methods. These are specifically designed to protect your eyes while allowing you to marvel at the celestial spectacle. Solar filters are like ultra sunglasses for your telescope, binoculars, or camera. They're made from a special material that reduces the sun's brightness to a safe, comfortable level, while also blocking harmful ultraviolet and infrared radiation. Remember, it's crucial to fit the solar filter securely over the front of your device, not the eyepiece. If you're using eclipse glasses or handheld solar viewers, make sure they meet the ISO 12312, 2 international safety standard. Alternatively, you could opt for indirect viewing methods. One popular technique is pinhole projection. This involves making a tiny hole in a piece of card, then holding it up to the sun, so an image of the solar disk is projected onto another card held beneath it. It's a simple yet effective way to observe an eclipse without any risk to your eyes. Or you could use a solar projection telescope. These devices project an image of the sun onto a white screen, which can be safely viewed by several people at once. One final tip. Whenever you're observing the sun, always remember to give your eyes a break every few minutes. This will help prevent eye strain and ensure you can enjoy the entire eclipse comfortably. With the right precautions, anyone can safely enjoy the wonder of a solar eclipse. Though the science behind the phenomenon of total solar eclipses may serve to demystify it, the experience of witnessing one remains just as magical. If you enjoyed the video, please consider liking and subscribing, as it helps our channel grow and continue to create new and interesting content. We encourage you to express your thoughts on the video in the comments and share our content with others.